find it interesting how people go from different careers. They like, how does the graphic designer end up, being in the water management industry?
No intentions of doing waterproofing.
Yeah.
No. Graphic design was me. Even architecture was sort of going those sort of directions. And just by chance, there was a good club happening. I think it was in Camden. Yeah. The old man said, "You come do some weekend work." Yeah. So, yeah, and then.
And so your old man was actually in the industry. He was doing the doing.
So he started off in remedial surveyor. So in the UK you have there's two qualifications. There's remediation, there's waterproofing. Remediation sort of encompasses timber, damp diagnosis, condensation, cavity wall ties, so all sort of property remediation from the roof down. And then you've got waterproofing, which is now sort of amalgamated into an association where you've got all of it sort of encompassed in one. But it was split as a separate subject. So anything below ground, and that goes 1, 2, 3, 4 levels down, covered roofs, podium decks as we call them. He was in the remediation side, and then sort of progressed to getting his own business, where he saw this product, which we're going to talk about today, and just thought, right, this is a new thing. This is going to happen. So, he started a company called Platonic Systems. That's a bit strange name.
Yeah. And so, how does it actually work? Like, what if you just like go through the nuts and bolts of the system? Because we were saying before, like, it's essentially water management, isn't it? Like you were suggesting.
So you've got a HDPE membrane.
Yep.
A very sustainable product.
If you hold it up to that. Hold it up in front of that one. Yeah.
So HDPE membrane, and the membrane has got dimples. These dimples are 8 mil in depth, and what that does is once you fix it to the wall, it holds it proud off the wall, so it provides a drainage layer. We use this a lot in historic buildings as well, so it still allows breathability. It allows air movement as well. But in underground or below ground waterproofing, it's fixed to the wall. Any water that comes in, once gravity takes over, it depressurizes. So you've got so much pressure behind, it gets to the surface, depressurizes, and what we're doing is just managing it, controlling it, and taking it to where it needs to be. So that's fixed to the wall. That's an 8 mil stud, and at the base of the wall, we'll go with the plug first. This is a multi-plug. So these are used to fix the membrane themselves. They have a polymer washer. They go in about 40 mil. They have a polymer washer, so once that's fixed in, that's completely sealed, and that fixes the membrane. And then that plug as well acts as a secondary fixing. So you can fix, if you wanted a closer fixing or finish to the wall, you can fix timber bands directly to the fixing itself, or you can use them as cavity ties. In commercial, they have solid walls, block walls, so they'll use them as cavity ties, and they're just spaced where they're needed.
And those are just they're just like when you do the old jib anchors at home. If you're hanging a picture or something into jib, you just drill the hole and push that in, and just hammer it in.
10 mil drill bit, and then you just hammer it straight in.
Hammer it in.
Yeah, brick plug.
Yeah.
Well, they used to be called, they're multi-plugs now. Multi-plug.
Yeah. That's cool.
But the original name was a brick plug. Originally they were wrapped. We had a butyl rope that you used to wrap around, and that gives you that compression seal as well. But as I say, technology moves on, and everything now becomes a bit more simplified. But the polymer washer, expands in the hole, compresses, and then that completely seals that hole itself.
Good stuff. When you say you attach it to the wall, so like the wall, is it generally a concrete wall? Or could it be a timber wall?
Yeah, no, it's concrete, nothing organic.
Nothing
organic. So it'd be concrete, it'd be brick, it'd be block. Once it's the rolls come in 2 metre high by about 20 metres long.
Right.
So they're rolled out, levelled up, and then they're fixed at certain points, depending where you want, or if you want to use these as secondary fixings, you'll do them at 600, 800 centres. But basically, it's rolled out, drilled in 10 mil drill bit, hit the fixing home, and then you just continue. So you just hang the membrane. So all we're doing is hanging it from top to bottom, and then that just sits directly against the substrate, the wall surface.
Right.
But any substrate in terms of solid, if you like. But anything organic has to be moved.
Right. And so you've got that sitting off the wall essentially, isn't it? Or it's sitting
on the wall, but with the studs sit it proud.
So then, what's the next layer after that?
So that's it in terms of the membrane.
Yep.
Once the wall membrane's up, and you've got the drainage system. So this is what we call a base drain.
Right.
It's a purpose-made drain. So if we shoot back, I don't know how many years, probably at least 15 years ago, the membrane itself, when it was first fixed, we never had the drain. So what we've done is either create chevrons in the concrete floor to just allow a path to direct the path of water, or we create a small rebate around the base of the wall, and then we'd fill that with a 20 mil stone or an aggregate. And the idea is water comes in, it filtrates in that stone, and then the water still is able to be taken generally to a drain within the sort of light well, because this was originally fitted as a refurb in London in small coal vaults.
Right.
So there was always a light well. Out in the front of the light well, you'd have a drainage system or a gully that you can discharge to. So once the membrane's up, this goes in, but this came in because of the issues that we found with the physical drain, is that they were blocking.
Yeah.
So you're getting silts coming through and fines and lime as well. London's got hard water, or England, so there's a lot of lime.
Over time it just blocks up.
It blocks up. So these were made to allow, as I like to say, an unimpeded access.
Yeah.
There's a void former, if you like.
Right.
That's placed at the wall floor junction where the membrane sits, either on the floor or within a rebate, and then it just gives a clear access that water can just channel through.
Okay.
And what it also does, it allows you to maintain it. So we have inspection ports that allow you to get back to the system and maintain the system at any time.
Are those the little holes in the side there?
No, the holes are more just for water to get in. The access points, there's a section of drainage, but it's got a preformed sort of opening that you can then attach a trunking, if you like, that allows you to get back with a camera or a jet wash and clean the system out. And that can be done on a maintenance, periodic maintenance, or if there is ever an issue, then you can always get back, clean the system to make sure that it's always working.
So you got the membrane coming down the wall. You've got the drain at the bottom.
At the bottom, yep.
And then, so once the water comes down into the drain,
yep.
What happens to it after that?
It will either go to
Would it have cesspits?
So no, not necessarily. I mean, what we'd like to do is have a pump. In an ideal scenario, we'd always recommend a pump, and then what we're doing, we're pumping on its own merit. So if there's ever anything wrong with the drainage system in and around the property, storm drain or anything like that, if that backs up, you get surcharge, this system is still pumping out, your property still remains dry. In a lot of cases, the client will want to go for something that's already there, something that's already existing. The onus is then on them to keep that maintained and upkeep of it. But yeah, ideally, first and foremost, it will be an independent pump that's positioned wherever it is suitable for the system. The drainage channel is then connected to the pump. They're all purpose-made chambers, so they've got their own outlets that it just connects to. And then in that, you'd have two mechanical pumps. We always put two, one in case there's a mechanical failure, so you've always got a backup, absolutely, yeah. And they're all bespoke to each job. Some commercial jobs will put in kilowatt pumps. Other jobs, they'll just be 250 watt pumps. So it depends on the floor print and floor layout, and also the risk.
Could you utilise what we've seen a lot is that we have in the underground basement in the car park.
Yep.
We'll have those spoon drains that you're talking about around the outside, and then they feed into cesspits in there. So would you utilise, say you were doing a retrofit, would you utilise the already stormwater system?
Yeah, you could do. Yeah, you could do. And we are doing that on a couple of jobs at the moment. A lot of one of the issues I've found here is some of the sites that are contaminated have got PFAs. So it's a result of fire extinguisher fire foam.
Oh, right.
Which is on site, and I think originally it was designed for sort of Teflon, things like that. But it goes for everything. It's very harmful for water. So there are systems in place designed by professionals to deal with that with the water authorities. So in those instances, there are pumps that we can identify. we can talk to those people and we can make sure that they allow for the system and the amount of water that potentially is going to go into those. So we can utilise systems that are in place. In terms of cesspits, existing drains, it's going to be one of those, yes we can, but the onus is going to be on the client to make sure that that's upkept and maintained, because it backs up.
Would become one of their, they'd already have, that side would already have a maintenance plan hopefully for that anyway, eh?
Yeah. How much water are we actually talking about? Because I'm thinking, shit, if you've got this in place, have someone not built something right, or is it, you know, I'm being a bit facetious, I guess, but at the same time, it's like, you know, how much water would actually come into a system like this on an average building?
I mean, look, in a new build, we don't expect any. It's a contingency. So on a new build, and whenever we design a system, and the way we work in new systems is we approach it from an outside in. So we'll take control and sort of lead the design in terms of the waterproofing, and that's speaking with the ground people, geologists, making sure that all of the land and the layout and historic data and the soil type and everything, contamination. Once we've got that sort of picture in our head, we can sort of start building a picture of what sort of system needs to go in place, and we'll always start from outside. So a tanking system will go in first. You've got your structure. We'd always recommend concrete as the best medium in below ground. And then this system goes in as a fail-safe. So if you've got a tanking system and your concrete structure as well, we don't expect anything. It's to say it's there as a contingency. So in a new build scenario, if anything, very minimal. In an existing, we'd still do our due diligence. We'd still make sure if there's water coming through, we need to stop that. We need to waterproof the structure first. And these are situations where you can't get outside, you can't deal with that. So in that scenario, we're still looking at minimal. I mean, the worst case I've seen this in the UK is from a flood, not from just everyday use where there's rainfalls. It's flood where you're getting a lot of water coming in.
So so it's not there as an excuse to not waterproof your building. It's
Absolutely
there as it's got to be part of the system that's going to manage any water that does get in. Correct. Okay. And do you find that that there's you're retrofitting these as well as doing new build stuff? Is it mainly is it like a certain age of building or a certain type of building that you install more of these on? Is it any building?
No, any. As I say, any building, any medium, as long as it's not organic. We do our due diligence first. We'll make sure it's watertight, and then the system's deployed. These in the UK is a hell of a lot of historic buildings, and they fit perfectly because they're flexible. Tanking systems, when they're put on, they can be quite destructive in terms of preparation and if they need to take it off. And one of the things historic societies like to do is know that a system can be reversed. So this is a reversible system. It's sympathetic because it's not inducing any further stress. Tanking systems designed to hold back. We're talking from the inside. And I talk tanking on the inside. Traditionally in the UK, tanking was the main form of waterproofing internally. So these have sort of come about, and as I say, in heritage, it just ticks all the boxes for flexibility, sympathy, if you like sympathy, breathability, because you've got air movement behind the system. So when you're talking about age, I mean, we're going back, Windsor Castle is one this system's in.
Crikey.
And you go back, Royal Courts of Justice. I mean, there's houses that date back 1500 that these systems have gone in. I mean, I can send you case studies.
Mate. And just go back to what you said there about the tanking. So if you've got tanking, is there a chance that you said something about it being like non-sympathetic or something like that? Would the tanking sort of hold back the water, but then the water's still pushing on the structure or something? Or what did you mean by that?
Yeah, I mean, it's one of those, with tanking, you've still got to make sure that the structure is capable of accepting that type of system. And with the older properties, if they've had a lot of water damage, obviously you've got your mortar joints and everything is breaking down. And so if you then put on a system, and the way technology works nowadays, these things are designed to hold back like 100 meter column of water, 10 bar on pressure. So you're now putting on a system that's designed to hold back that type of pressure. And if you've got that pressure behind, you could actually be doing more damage to the structure. But also, as I said, when you go back to the historic properties, to actually get that to do the correct prep, you're damaging the surface potentially, especially where you've got, so I'll refer back to London again, you've got old stock brick that once it's wet gets very soft. You know, so it's actually not capable of taking that type of system. So again, these cavity drain systems come into their own because you're just minimal fixing. You're not changing the status quo. You're not inducing that pressure any further. You're just allowing to happen what happens. I mean, you minimise the water coming in, but in most cases you haven't got running water. I've never really seen a case, and I've been doing it 26 years, where you've actually got water running. Yeah. You know, running through the property.
You've only got bigger problems, eh?
You've
got bigger problems.
Yeah, exactly. And that's and people say to me, you know, what if you've got that much water coming in? And I say, well, someone's not done their job, you know, because you should never have. I mean, this is capable of doing 6 litres a second. If you've got that much water coming in, you got issues.
Maybe move.
Bigger issues. Yeah. Get a boat.
Live in Venice. You probably do live in Venice. So, is it mainly for like below ground stuff? Or can you do it slightly above ground, or is there any need for it slightly above ground?
Not really. I mean, the system originally it was designed. This one here. This is a mesh. So it's exactly the same concept. John Newton and Co. Who I worked for Newton Waterproofing Systems for 14 years in the UK, and John Newton and Co. were the sort of pioneers of this type of system. They've been going since 1830s. Their sort of entry into construction was horsehair. They sold horsehair to plastering companies who done traditional lard plaster. Well, that company then, so that was their entry into construction. And then in the 30s, the then chairman went to a fair in Germany and found a product called Kragita, which was a fiberboard, which was dovetailed, so it had the flues, if you like, so that channel, and it was dipped in a pitch, so it became waterproof, if you like. And that was put into properties after the war. There was a lack of housing, sort of families living in rooms. So there's a lot of issues with damp, a lot of condensation issues, and this was put in. I think it's roughly about 6 million meters of it over a period of time. So it's a very successful product. But then they started using it below ground as well. But the concept then of having it as a damp proofing system continued on, and this one, as we call it, System 800, is used above ground, and the idea is that you're not dealing with the dampness, you're just sort of isolating. It's the same with the waterproofing below ground. You're not waterproofing the structure, you're controlling it, you're managing it. So it's the same above ground. The difference above ground is you don't need required drainage channels. So you're fixing this to the wall. You can do a direct finish. You're isolating the damp system, and it becomes a damp-proof membrane, if you like. And that only goes up sort of 1.5 a meter to 1.5 meters. So you're not doing.
Would they class that as is that a vapor barrier?
Yes. Yeah. So it does 3 things. It controls water. It isolates capillary movement. And reduces vapor. So internally it provides a healthy environment because there's so much vapor movement coming through.
So then, we were saying before about how it's applied, and so you got your wall, you got your drain down the bottom, and then do people generally put like a jib or plywood or anything else?
There's many finishes. The most traditional finish on the mesh system is a dot and dab jib. We get used to jib. Sounds like plasterboard.
Plasterboard. Sorry, it's a Kiwi thing. Aussie.
On the walls, I would say commercial. Normally they want a solid wall. So they'll build a block wall in front, and then they'll use the plugs, the fixings to tie off. In residential, they tend to go with timber battens, so they have a closer fix, so you're losing less space, and then jib on straight on top. And then on the floors, once the membrane's on the floor, so the same membrane goes across the floor. It's not fixed; it's just loose laid and then taped around the perimeter. And on top of that, if that's directly on the concrete, you can put a low timber floor if you want, because straight away you've equalised the floor. There's no vapor movement. There's no damp.
Can you fix directly onto that? Could you lay a floor directly over that?
No, it's got to be floating. It's got to be floating. Excuse me. In the new specifications with regards to commercial and residential, high-end residential, if you like, because it's a bigger space, the drainage system goes in, and we have insulation in front, a 50mm insulation. The main reason that came about was a combination of 2 things. One was the original is to cut a rebate. and that messes with the engineer. The engineers don't like it because you're cutting into their floor.
Into the normally that foundation ring.
Yeah, and they have to start messing about with steel. So they're moving steel detailing to accommodate this channel. In existing, you're cutting out a rebate, and obviously you can't hit the steel. So the new way of installing, say new, it's quite common now, is Part L requirements, which is your Part H insulation, came into play. So we took that insulation and we use it as a void former.
Right.
It's an XPS insulation, so it's got a very high compressive strength. It only absorbs about 1 to 2% water over a 50-year span, and so that means we can put the drainage straight on the slab, insulation in front, and then the membrane just sits on top.
Sweet.
Yeah, and that does two things. It stops, it takes out the need to create a rebate, but it also gives an insulation that the designers can then use in their calculations. And it brings the floor back up. So everything there is in the wet zone, hence why we use XPS. And then on top, the finished thing is generally a 65mm sand and cement screed, or wear, I think you call it wear slab. Call it wear slab, yeah.
I don't even know what you're really talking about there. Is it a poured like a concrete type thing?
Yeah. Sounds. I get wear slab. You play with words there. But
So people really can reclaim they can reclaim basements that would otherwise be uninhabitable.
100%, yeah. And it's a very quick and non-destructive system to put in.
Yeah.
And you've got, as I say, if you use the insulation, I mean, air's the best insulator, so you've already got an insulation there. With the insulation there, you're meeting the Part H requirements as well. In the walls, you can add insulation as well. So everything happens inside of the system as it normally would, and you've got full protection from the outside coming in then. But as I say, it is a retrofit. It's become more apparent in the UK because of the requirement for 2 forms of waterproofing, which isn't the same here.
Right.
So the approach here, which it is in the UK as well, is from the source on the external side. But if there is a failure, or if you can't get to the outside, you know, what are the options?
That makes a lot of sense though, because I mean, like you say, you got the tanking on the outside. If that fails, this is the next barrier.
Yeah.
So what do we have in New Zealand then? Just the one, like the outside thing?
So it's looking at if we can tank or repair from the outside. If it's not feasible or economical, then it's a tanking on the inside. It will be a similar type of system on the inside, and that would either be cementitious or a peel and stick type, you know, and then loaded from the inside.
When you're holding it up before, talking about the floor, do you have to allow for like a certain amount of fall? Like, does it have to be able to drain away, or does it just sort of evaporate over time when you're laying it?
Yeah, no. So the base drain sits level. Water will always find its own hydraulic level.
Oh, yeah.
So we put that in level, and that again, the engineers like it because they don't have to. It's costly to try and get a level in with slabs these days. So we just say, you know, do your job, lay the floor as you normally would. We want the structure to be the primary defence. We want it to be as watertight as possible, and then we'll just come in and everything sits level and then fixed. So yeah, that goes in level. Everything will go in level.
It's like when you see a nice concrete slab poured, and they always seem to put the drains in the wrong place. Like there's a massive puddle over there, and there's a drain over there which has got no water around it. Yeah, that's a classic. Thomas, because I guess we're sitting here because of our chat that we had a couple of weeks ago. How does this sort of intersect with your business? Like, you know, how did you guys sort of come across each other for a start, and then, you know, is it something that you'd recommend to your clients as well?
I think it's one. We'll always go somewhere and help someone else with a roof leak or a membrane leak, and then sort of as we're packing up, and this has happened for a decade, is would you be able to come down to our basement and what can we do here? And sort of always been like, well, that's a tanking thing, and my answer before was, so there is people who do concrete injection and that sort of stuff, but people can spend a lot of money doing that and really only move the leaks. You still have the leak. And then finally came across Newton Systems, and it was sort of like, well, we just let it happen and deal with it. Like the concrete's not being damaged. That was a misconception I had too, like that the concrete, but really concrete's denser than water, so it's not.
It's always wet.
Yeah.
It's always wet. Yeah.
So it's just going around it, really.
Yeah. It's it goes back to the standards as well, and that's the New Zealand standards and codes and the British standards. So we have a standard just for waterproofing, which has changed our industry. That came out and really sort of had presence in the 1990s. There's a court case as well that really influenced that, and insurance companies. They were bearing the cost of a lot of poor design, poor workmanship. So the standards here, and one of the things that in both standards is quite clear, is form and feasibility, consequence of failure, and then form and feasibility. So really, when you're designing a system, you should be designing it with in mind that there may be failure, and how do I get back to remedy that system? And the answer is, with tanking systems, on many occasions it's virtually impossible, or if it is possible, very expensive
to take it back.
So and that's why the two forms of waterproofing, because we've got the standard, the two forms of waterproofing, so that consideration has come in. Okay, so that's failed. How do I get back? How do I deal with it? We can't, so we're gonna detail in or design in a fail-safe system so that we can maintain it and monitor it throughout the life of the building. And that's again where this cavity drain system has really sort of picked up. So you've got consequence of failure, form and feasibility.
I like that comment that you made about like just let it happen and then deal with it, manage it. Because we've managed buildings over the years where people have driven themselves nuts, like owners have driven themselves nuts, like wanting to fix that little leak in the basement car park. And they're going, oh, we need to fucking stop that, it's going to ruin the building. And it's like, so to hear you say that is actually really like reassuring, because quite often you can't stop these bloody leaks. They might be even like a couple of stories underground. And you're like, well, okay, you're going to spend like $100,000 digging a hole and then try and find out where it is, or how do you even find where it's coming from? You'd have to do dye testing and all sorts of shit.
And it comes, it's just massive investigation. And as Thomas said, you inject water will take the path of least resistance. So if you stop it at one point, it will. And if it's coming through, I mean, what you're relying on is that tanking behind is fully bonded, and you've got a defect, and you can see the defect, and the water's coming through. You've isolated that. You've dealt with it. In an ideal world, it's gone. But over time and over many years, those systems break down. You don't know when you've gone from site, what's happened to your system afterwards. If it's been exposed for too long, if the tradies have smashed the out of it.
That's one of your common things, eh? You'll bloody nice membranes and stuff after that.
Yeah, absolutely. So you've got and trying to chase water, it's just not going to happen unless you have all those things come into play, and you're like, yep, no, this is fine. We saw it just before you covered it up. Perfect. So we know that leak's coming from there because it's fully bonded. It's just not going to happen. So it's one of those ones you've got to try and you've got to future-proof. So and that's what we do in our designs. We sort of take the client on a journey in terms of, this is a system, and over time this potentially could happen. You can't rely on a tanking externally to be 100% defect-free. This is not possible. So you have to consider form and feasibility and future-proofing.
So that I was going to ask before about the difference in, I guess, technology, or where things are at compared to the UK or Germany, compared to New Zealand. Like, are we in New Zealand, are we sort of a bit behind the eight ball with this sort of building technology, or are we up there, or where do we sort of fit in the global scale?
In waterproofing, the products, it's more down with the products and techniques, and I think it's because the UK, if we compare it to the UK, because we've got a standard that deals with waterproofing as a whole. So that then is put together, and sort of everything, all the influences is from specialists, waterproofing specialists, designers, engineers, insurance companies. So they're looking at the real world and how we can mitigate this, how we can put systems in place to deal with these failures. But I think with New Zealand, and the onus is on the installer as well. The contractors are an association. They take PI for design, for example, and so they want to make sure that system's designed in place. So there's always innovation. There's always looking at new techniques, new products, what works, what doesn't work. And because the contractors are sort of at the front end of it, they're installing the products. They know what works, what fails, what's good, what's not good. In New Zealand, it's more, you've got your building codes. The building codes reflect the standards that we've got in the UK. The practices are fantastic. The installations are there. The tanking. There's just no involvement. Is that the right word? Yeah, involvement.
It is now. You've made it a new word.
Yeah, awesome.
Evolution.
Evolution.
There you go.
Coming on the inside,
Yeah.
it's still the same sort of practices, from what I'm seeing anyway. Which is tanking. So it's like that's the only form of waterproofing that's been considered. So it's more just, I suppose, like myself, bringing in this product and saying actually this works. You know, it's been used since the 1930s in the UK, designed before that, and this is how we use it, and this is where we use it, and just more an education. But it's also got to fit in the standards. You know, your standards are quite strict on it. You need to do this, and this. Whereas our standards are sympathetic in the way that, yeah, there is failure, so, you know, we're not going to be able to keep the water out.
Yeah.
We have got an alternative solution, and it's not going to impact the structure because you've done your due diligence. You've had an engineer look at it. So this is an acceptable solution. So it's more just, yeah, updating those practices, those ideas in terms of waterproofing. Ideally, you want a standard that just deals with waterproofing.
Yeah.
It's quite a complex subject. It doesn't just deal with the structure. You've got to look at the whole aspect, and that's what I talked about, the court case that sort of changed our industry. Part of that was that the external system failed, but they didn't, in the design, they didn't consider the whole of the waterproofing aspect, which included the external drainage and the fact that that was in the wrong position and that was delivering water and that was causing, you know, so it's looking at the whole thing. And that, so when you talk about waterproofing and when you read our standards, it covers absolutely everything, not just a couple of obvious details or, you know,
more holistic management of the water.
Absolutely, yeah, from beginning to end.
So from a business perspective, like, are all these products here, are they all sort of they patents, or like is there like
so
a
this is all the whole is Newton System 500, so it's all co-marked. Newton waterproofing,
because there's a 500 and the 400, eh?
Yeah, so the 400 is an external. It's called Hydrobond.
Yep.
Hydrobond 400. So that's an external tanking. That's a fully bonded system. There's quite a few of them already in New Zealand. This one works. It's got a fleece. Once it's installed, it's got a fleece. Once the concrete's poured, it interlocks with the concrete. Benefits of that is that, you know, if there is a defect, I was saying earlier, as long as it's fully bonded, that defect will come through that hole. It won't creep behind the product because
delaminate it.
Yeah, and it's got a hydrophilic core as well, so it will expand. So small defects, which you tend to get with the ground workers, with their stills and a bit heavy-handed, they'll self-heal. Bigger defects, you hope, as I say, with a fully bonded system, and that will be similar to a few systems here in New Zealand already. But the systems we have, the idea is they are systems, not individual products.
Yeah.
We're not about just selling a product. We're about providing a system and solution. System 500 encompasses walls, drainage, floor, pumps.
Right.
System 400 is external full tanking, if you like, but also detailing penetrations, which tends to be where they fail.
Yeah.
Penetrations and detailing, so taking a more 3D look at external.
So obviously I noticed that those are all made out of plastic.
Yes.
And do you get them manufactured? Are they manufactured in China, or whereabouts do you get them made?
Manufactured in Germany.
Germany.
Right. Yeah. Okay. So manufactured HDPE,
Yep.
Which is the most sustainable plastic.
Because that's I guess that's probably a consideration for a business now. It's like, you know, everyone's into recycling and all that sort of thing. So do they make it out of recycled plastic, or? Yeah,
it's all recycled. New waterproofing systems in the UK are putting a recycling machine in their unit. So when all the systems use any offcuts, they have a scheme where when they deliver material, they pick up all the offcuts.
Yeah.
They take it back to the warehouse and they recycle it, and that gets sold into I think into a pipe manufacturer. They remake pipes for the construction industry.
Great.
And then the money for that goes to, at the moment, I think it's sewage cleaning the estuary and riverways around the UK. So it's something we'd like to emulate here.
It's a really good environmental awareness program there, eh? That's awesome. I wasn't expecting that to be part of the conversation, but mate, I've thought of that as well.
Well, I mean, it is plastics. It's a dirty word, isn't it?
Unless you want to stay dry.
Unless you want to stay dry, yeah. But it is. I mean, there are unknowns about it. It is a very HDP, especially because it's recyclable and everything else. It's one of the most commonly used products because of its versatility and it's durable. And that will probably last longer than the building. So when you say sustainable.
Yeah, that's right.
So we're doing our bit. As I say, we're very young here. We'll say young. We've been operating in New Zealand probably 10 years now. So I've been designing from afar. Moved over end of last year. But so as we're now starting to get going and progress, these are all ideas we want to sort of encompass and bring on board.
The installation's got to be the critical part of that system, eh? Like you've got to make sure that it's installed exactly how it needs to be.
Yes.
Do you guys have your own team, or do you sort of have? Is it like a franchise thing, or how do you control the quality of that installation?
We have installers, approved installers, Newton approved installers, and they're peppered throughout the country. We currently have about 4, 5 up and down New Zealand who install this. The training is twofold. They go back to the UK and they'll do training there. So they'll get a whole concept and a whole idea of waterproofing as a complete subject. They'll learn about the standards, go to sites and muck in with the guys over in the UK. And then here we do full-on training through us. We'll go to site, do the QAs and similar sort of program, because I've done all the training in the UK, so I'll emulate the same program here. But they need to be involved in waterproofing, So they need to. It's not just about installing a system. As I said, it's a complete subject. So they need to be able to walk into a property and say, okay, there's other stuff going on here. We're not just going to throw this in and walk away. We need to be able to do this. So they need to be waterproofing minded, waterproofing specialists, and the system itself. Once they get going, all that training and everything comes on board. So
I remember when I started talking to Thomas about ILD, there was a hesitation, when you guys go to site. There was that initial hesitation where they're like, oh, we don't need this bloody testing or this product or whatever. I wonder if you would have found the same sort of resistance or hesitation when you came into the market. Was that the case, or were people like, finally someone's got a solution?
No, absolutely. It's weird, because I mean, in the UK you get used to people saying that bubble wrap. We don't need that bubble wrap. And as I said earlier, they've got a concrete structure, they've got an external system, and we're coming along and putting in bubble wrap, as they call it. But when it rains, concrete is inherently watertight, but you'll start seeing it come through the joints. You'll start seeing it come around details where here it's been interesting because you have the conversation and it's not a waterproofing system is what the thinking is here. So where does it fit? And originally I've had the conversation with council and they say, well, it doesn't fit the codes because it's not waterproofing, it's water management. So it's interesting. It's starting to progress. I think it's been an education thing on their part to me and my part to them. But the reception is, it's been okay. People are accepting that this is a viable solution. I think
it's a different way of dealing with the problem, eh? Water ingress is the problem, and it was. You got tanking as a solution, which is probably widely accepted here. You've got membranes, and then this is just another way of dealing with the water. And people should be a bit more open to the fact that it's another solution rather than going, no, we're good here. Because for all we know, that might be the best bloody thing since sliced bread compared to all these other things that are more widely accepted. And it's just, I guess, it's time. You just got to have time to convince people.
And I think once there's been a few installs as well, so that we've got some case history built up there as well. I mean, we've done a few jobs already. We've got some big ones on the go. But it is, I mean, at the moment, I was speaking to council not long ago, and one of the issues I'm saying that you've got, and same in the UK, same worldwide, is the characteristics of the products. So if your solution is to put a tanking system on the inside when a tanking system on the outside's already failed, and the structure's moved and cracked, the characteristics of the property, the structure are all the same. So what's going to happen on the inside? So you need to sort of think outside the box a little bit, unless you're going to redo the structure. And in most cases they can't. We're looking for remediation. Then you've got to look at a system that can deal with, if that's cracked or broken at a joint because the structure's broken, cracked, then this is a system that won't. So you haven't got the same product characteristics.
I think if
Do you get what I mean?
I think if the people who have a leaking basement could hear, who are way down the track with their property, and they're hearing someone who's building something new, that doesn't think of this as an option, that would be highly frustrating for that asset owner who's gone through all those things and now has a wet basement. That would be highly frustrating.
I think the key to it is we're not letting water in. You know, we've done everything we can to stop water coming in. So what we're doing is we're basically putting in this and saying, like, you know, we can't do what we want to do and deal with it at source. So you've got to have a mindset that there may be seepage now. So let's deal with it.
Yeah, that's right. So Thomas, when you sort of discovered this, like, because I know you know, it sort of rang a few bells for you. Like, did you? And you obviously sort of recommended it to people over the time. Have you sort of seen any like of the success stories about the system in action? Did you go back and sort of check that sort of thing? Like once system's in?
I've seen the case studies of it, but I haven't sort of. That's the when you say that there's this option available, there is without someone like yourself. It's hard for them to believe what I'm saying, or you know. So that what I think it is what you're saying before, with it being a time thing. People will get that or be more accepting of it. But I think the ones that help that time thing are the ones who are dealing with the worst case situations, you know, who think there are no hope, and then someone comes along, I bet you they go, we'll give that a go because we've tried everything else.
I mean, we've got some real good case studies coming up, which is they're spread all over the different types of constructions. We've got a new build in a CBD, which is quite a large project. We've got one in Christchurch again, which is it's a new build, but this is more of a dewatering. So they put a few extra contingencies in the wall, so we're just doing the floor and the drainage and sort of coming up slightly. And then we've got I don't know, is Wellington Town Hall historic? Would you say it's a historic property?
For New Zealand it is.
It is, yeah. Oh no, very proud of this one. So they've lived. I mean, I don't know if you've seen the on LinkedIn. They've got a video with Naylor Love of how they've literally lifted the Wellington Town Hall, and the engineering is phenomenal. So I've been dealing with that for about 6 years now. It's been a real long process. So we're doing all the cavity draining there, and there's part existing, part new, but it's all going to work with the building. And that's what I was saying earlier with this being flexible. But these are all different case studies showing different building materials, different situations, different elements that we can now sort of go to people and just say, look, you know, we've got different scenarios where we have stopped it, or we have put 2 forms of waterproof, or we can't do anything here, and this is a viable option. So I think with that and just more of an explanation of how the system works and that we're not allowing water to come in, we are doing as much as we can, we'll start hopefully gaining a bit of pace.
Getting the word out there, because I mean it is a product that is for like your residential house with the old concrete basement or whatever, like you said before, or it might be some bloody great big apartment building with a concrete basement, or an office building. But it's trying to figure out how do you get the word out there to the people that manage and run these buildings. So hopefully this will help a bit. And you know, because I thought, who would I bloody go to for something like that? And historically, you'd probably sort of throw your hands up in the air and go and call an engineer or whatever, and they'd come up with some, bloody plan or whatever. But mate, this is such a cool product and system.
Or some fees. You get a whole lot of consultancy fees along the way, and you get to the end, they go, but it's not real.
But it's slowly making. I mean, it's in the UK. It went the same way. People were like, nah, and then it started off in small, dingy vaults under the pavement where they used to throw coal in. And it's like they used to use cementitious traditional tanking, but because then the roads are getting busier, more work's going on, they were cracking. So there's a lot of vibration. So then this system started, just little one here, little one there, little one here, little one, then all of a sudden, you know, it explodes, and people get it. So yeah, I mean, it seems to be going along that path.
So, I guess to use a modern sort of term about, is that term of being a disruptor, you know, in an industry. If you're coming in with something that people have never seen before, they need convincing, but they're also going, shit, this might affect my business. You know, they become defensive and all that sort of thing. So I guess it's trying to figure out who to work in with and how to get round those established players. You know, because I'd imagine you can work with some of them. Some of them be quite open-minded.
With all of them, I mean, it's a combination thing. Part of the standards that I was working to and still refer to, which a lot of the architects are referring to, you have A, B, and C. So you have Type A, Type B, Type C systems, and it's a combination. It's looking at what's the best solution. So when I'm approaching a new build scenario, I'll be recommending an external system, you know, and that could be one of many that are already established here in New Zealand to work with me on the external and internal. So it brings in the industry. It should be an industry thing, not just a product thing. You know, it's all about waterproofing. And this system, can be in combination, and even on an internal system, there may be detailing, there may be penetrations, there may be things that, you know, other products will be better to deal with, to go working hand in hand with this system as well. So it's some people are going to get there's always a few there that are going to get knocked off with it, but
that's just life, isn't it?
But the idea for me is to bring in the A, B, and C. So A is external tanking, B is integral, so it's your structure, and then C is your Type C cavity drain. We're bringing those in and we're finding a solution as an industry, and working with all of them hopefully.
Good. What was the opportunity to come to New Zealand? Like, where did that come about? Were you quite happy back in the UK, and then it was like, come to New Zealand?
I married a Kiwi.
Oh, you're right.
Married a Kiwi. Married a Kiwi, and it just so happens around about that time, this guy came in to Newton's in the UK, and he was living in New Zealand. It was just like, I love this product, I want to take it to New Zealand. So it all sort of fell in line somewhere down. So I continued designing the systems for a number of jobs here while I was in the UK. And then a few years back, we were sort of had enough. I say had enough, but UK, you know, life was getting quite busy, a little bit stressful, and also the wife had been in the UK for I think 18 years. So it was sort of time to
come home,
spend time with her family as well.
Nice one.
Well, what a beautiful place as well.
Man.
Apart from the rain. What's going on with the rain?
What rain? Hasn't rained for minutes.
I left the UK for that.
You brought it with you. So from if you got your graphic designer hat on, you know, obviously from a design background, do you ever look at a product like that or that product or anything and go, oh shit, they could have done this a bit better, or is that a really well designed product from your design perspective?
I mean, we have. I mean, I've had the benefit and luckily the privilege to help Newton Systems redesign a number of different products over the years, and we've got it to a point, I think, where it works in most, if not all, scenarios.
Would you have to do different designs for different countries? Like New Zealand would have different design components compared to, I don't know, the UK or Germany?
No. The system remains the same. There may be alternatives of it, but in the concept, or as I say, the design, or the to achieve the same goal. In the water comes in, we manage it, it drains away. As I say, the one in Christchurch we're doing, they're not putting full system up the walls. So we've looked at how we maintain the system in terms of removing water, collecting and removing, and we've put in what we call a dewatering system. So that includes mainly just the floor with a small upstand. So there will be different designs based on, you know, different circumstances, but in terms of the components, they're also the same. I think the only thing I'd like to look at changing would be the drainage channel, where we have to rebate it if we could have a thinner one.
Right.
But the issue with it is we need to maintain the volume.
Do those holes need to be that size?
No, they can be smaller.
Yeah.
I mean, these are in there because when the system is actually on the slab and you've got the insulation detail we spoke about, if there's any water in and around, it's still, you don't expect it to, but it's there to allow water in. But they can be smaller and more frequent, or bigger and less frequent. You know? Yeah, but it is a void form. It's not actually a watertight product.
Yeah.
Yeah.
Interesting. Oh, that's cool.
It almost seems too simple.
Yeah.
Yeah.
Yeah. But I guess that's the thing, eh? Like, a lot of things that are simple are really effective, and you know, that seems to be the bloody.
I mean, I spoke to a contractor down in Christchurch. He'd never seen it, and then I went down there and I sat with him, and within 5 minutes of putting the components together and showing him and explaining, he's just like, I've got so many jobs I can use this on.
Wow.
Yeah, where we're chasing and chasing and chasing. What we said earlier, just chasing leaks. Call back a year later, still coming through, chasing leaks. You know, yeah. So I mean,
what about the insurance aspect?
Does what it says on the tin. In what respect?
In the UK, is it? This comes with insurance. It's not necessarily warranties.
No, it's different in the UK because of the history, because of the claims and the court cases and things, and because of the standards as well. When you specify the system, design this system, it's a full report. You have to take into account, as we said earlier, the ground layout, the water tables, the soil makeup, and everything that comes with that. And that's from the installer, the contractor, the specialist. And then once it's installed, they'll offer an insured back warranty or guarantee. They'll offer their own guarantee, and in some instances they'll take PR on the design as well.
Yep.
But that's come from a lot of history, back history. Obviously here it's slightly different. The onus is on the designer, who then passes it to the specialist, who then sort of overlooks it and prices it. What I'd like to see, I mean, I'm only new here, but is more onus on the specialist being involved at an earlier stage within that design team, so they have an influence on the design, because the advice of a specialist is paramount. They know what's going to happen. They've been doing this for many years. They're looking at products, not just products that are flavour of the month, but products that are used, tried, tested, in situations, in ground conditions, that is suitable for those products on that type of structure. So having that specialist in at that stage will put more onus on. So therefore, the expectation is you're taking the design responsibility, and therefore the expectation is you need to provide all the different insurances and PI.
Yeah.
But here it's more the design's already done, and it's more So that again, that's sort of another industry conversation, I think, as things are moving, and they all seem to be moving, from what I can see, in quite a good way. And I think the floods have really brought that together as well. So yeah.
It often takes a bloody disaster like that to get people A into G, doesn't it? So
absolutely.
Yeah. Well, if that's some good that comes out of that, that recent sort of issue, then all for it. So just one thing I was going to say just before we wrap it up was who do you guys actually go out and sort of target certain companies or industries to say, here we are, this is what we do, and here's our product?
It's like all sort of waterproofing suppliers. We're a waterproofing supplier. We've got a website. We're there to help with design. What we offer as a company is design, supply, and the install part of it as well. So which they would as well, other suppliers. We'll look at design and take ownership of the whole waterproofing design and guide or advise all the way through, hopefully from design stage, and then obviously the product, and then we can appoint an approved installer or three to then look at that, oversee that, and price for that job as well.
Okay.
But yeah, the idea is we're looking after it from design stage and making sure for the client that they're getting the internal environment that they want to get. Yeah.
One thing that just popped into my brain, another thing is there a certain size limit of job that you can do, or could you do a bloody rugby field or something like that? Is there a limit?
No, there's no
big as you
limit.
want.
Big as you want. I mean, the only thing we need to be mindful in terms of design is making sure we can manage that amount of water. We've got to look at worst case. We design to full height and we design for worst case. Worst case is this system is fully surcharged. So we need to, although it never will be, this sort of flood event. That's the only consideration. But yeah, in terms of it's like Lego. You know, the studs are interlocked. We have butyle tape, and you just click. So it's
that's cool.
Yeah,
that's bloody interesting.
Gets easier, doesn't it?
It's good. Thanks, Thomas. I'm glad you put that together, mate. Yeah, it's been really good to learn more about that product, man, the system and stuff. And yeah, we'll push it wherever we can, because, like I said, you know, there's a lot of buildings out there that have got the issues, then they need this as a solution. So good on you for bringing it to New Zealand.
Yeah, no, happy to help. Thanks for bringing me in and talk about it. Yeah,
cool.
no, and I mean, it's not always fit for every scenario, but what I find it's in a lot of cases the idea. Once you push the idea and people see the concept, they're like, the box starts. You know, people start thinking out and looking at other options. So even if it isn't, it does, you know, push people to start thinking that there are other options. That I don't have to keep forking money out to all the time.
Yeah, exactly. No, that's it. Awesome, mate. Thanks for that.
No, thank you.
Cheers.
Yeah, thanks very much.